Someday in the future, and sooner than you might think, people will live on the surface of an alien world. Those people are students today, learning about spaceflight and the life sciences that make it possible for us to work and live beyond our home planet. Education is the launching pad for that adventure, and science is the fuel that will prepare and propel our future efforts in space. NASA Space Life Sciences outreach programs are like launch vehicles that raise our awareness and inspire the next generation of space explorers to prepare for the challenges that lie ahead, giving them glimpses of future destinations and hints at how we'll get there. One such NASA learning platform is the Scott Carpenter Space Analog Station, a working model of an off-world outpost built to operate on the ocean floor, the closest thing on Earth to the surface of an alien world. The Carpenter Station was designed specifically to demonstrate to students concepts of the life support systems so vital to our future space endeavors. The program is part of NASA's Space Life Sciences outreach effort, known as MARS, which stands for Mission to America's Remarkable Students. The Carpenter Station's mission is to teach and inspire students, reaching them in the classroom by teleconference, video, and by direct visitation, where hands-on inspection brings the abstract ideas behind life support into understandable, concrete reality.
Oh, it's pressurized. It has air in there.
By offering students direct access to a NASA program, the Carpenter Station brings the role of spaceflight down to Earth and gives students a more compelling picture of the opportunities offered by careers in space. You may think that the environments of sea and space are worlds apart, but the two realms actually have a lot in common. NASA's Rose Grimes explains some of those similarities to students at the Kennedy Space Center in Florida.
The Scott Carpenter Station is a space analog station, a complex model. The ocean environment mimics the space environment in a number of important and useful ways. Atmosphere. There is no breathable atmosphere in either environment. Both are isolated, remote. When explorers leave the haven of the Carpenter Station, they experience a simulation of weightlessness, buoyed by the water of the ocean environment, and thus perceiving less of the effects of gravity. We are highly adaptable beings, but individually, we are fragile in the face of some of the environments we encounter in our adventuring. We need to take with us our atmosphere, our food and water, protection from heat and cold, communications, and methods to monitor and regulate our environment over time. In these requirements, a submerged habitat is an analog, a model, a mirror of a lunar installation, spacecraft, or a planetary exploration habitat. This is why NASA Research and Technology is represented by the Carpenter Station.
With so much in common, it's not surprising that sea and space share a history of cooperative efforts dating back to the early days of the nation's space program. After commanding America's second orbital spaceflight in 1962, Mercury astronaut Scott Carpenter became an underwater pioneer, helping NASA and the Navy learn from each other's experiences in the challenging frontiers of sea and space. In 1965, Carpenter commanded the Navy's Sealab 2 undersea habitat, living and working for 30 days on the seafloor off the California coast, 200 feet beneath the surface. In addition to groundbreaking scientific achievements, a symbolic event was accomplished on Sealab as Carpenter connected with fellow Mercury astronaut and friend Gordon Cooper, circling Earth aboard a Gemini space capsule. It was history's first conversation linking sea and space. Since that time, NASA has made good use of underwater environments to help astronauts prepare for the challenges of working in weightlessness and living in remote alien conditions. To acknowledge the mutually beneficial links shared between sea and space, and to commemorate the 30th anniversary of the first sea-space connection, A second link was accomplished in 1995, with Scott Carpenter again speaking from and for the seas. His space-bound counterpart this time was shuttle astronaut Mike Gernhardt, himself an experienced commercial diver.
Right now we're over the Pacific Ocean, and I tell you, you read in all the books that the Earth is 3/4 ocean, and you accept it intellectually, but it takes getting up in space and looking out the window and seeing just how beautiful, magnificent these oceans are to really fully appreciate it.
You see the big picture. That's very important in order to protect the ocean. But we see the detail here, and both of these views are important if we are to save the ocean.
Well, I agree, Scott. I think the things that you're doing there and the things that NASA's doing in space are a good point of departure to get kids motivated and again, let them see that anything is possible. And I think when you can put that thought in a child's mind, it makes the world a lot more interesting place for us all to live.
The underwater location for this historic link was a former research laboratory based in the Florida Keys, operated by the Marine Resources Development Foundation. NASA had used the habitat before as a test bed for future space missions. It was here that the inspiration for a NASA-built undersea station took shape, as NASA employee Dennis Chamberlain performed experiments in MRDF's undersea habitats to better understand the challenges of growing plants in remote, hostile environments. Based on that experience, and in response to new educational and outreach priorities set by NASA, Dennis designed an undersea station to serve as a space analog or model that could demonstrate to students the concepts of life support systems. Dennis is the chief designer and principal investigator for the Carpenter Station. He also served as its mission commander for the 3 missions that occurred in 1997 over 14 days on the sea floor. As a former United States naval officer, nuclear engineer, and NASA bioengineer at the Kennedy Space Center, Dennis is convinced the Carpenter Station's mission will have a positive impact on the nation's students.
One of the most important things about the Carpenter Station is that it really works. It's the real thing. When we set the habitat down on the bottom of the ocean in 1997, it became one of only 4 functioning habitats in the whole world. And it is therefore a life support system for real that we take to the schools and that we can deliver to the students something that really works. It acts, of course, as a model for the space environment. We can't bring the space shuttle to the schools. It's unfortunate, but we can't. But we can bring the Carpenter Station to the schools, and the students can come into the station and sit down in the chairs and touch the real thing and be a part of the real thing. And it's just an experience that they just will not forget. It's a duty that we owe to the American people to bring this little piece of the space program out to them, to these people who in the next generation will become the settlers of the new worlds.
The primary influences on the design of the Carpenter Station were size, function, and cost. Since it had to be easily transportable, it was built to fit on a truck flatbed and resembled a futuristic minivan, but weighed a whole lot more, 10 tons, or 20,000 pounds. At that weight, it would be heavy enough to compensate for the effects of buoyancy in the ocean, but not too heavy to launch from standard boat ramps and travel to schools for on-site inspections. Its functions were designed to be very basic. As an ambient pressure habitat, the Carpenter Station was not designed to be pressurized. Water was to be kept out by a steady supply of fresh air pumped in from the surface at a great enough rate to compensate for the surrounding water pressure. In addition to receiving topside air, the station was designed for surface-supplied water, communication links, electricity, and air conditioning. Fitting within a space no bigger than the shuttle's flight deck, onboard amenities were to include a refrigerator, microwave oven, shower, toilet, telephone, radio, video, laptop computer, and 2 reclining chairs that would serve as beds. A surface support buoy was designed for seafloor-to-shore radio communications and to serve as a surface beacon. Dennis worked with engineer Joe Bishop to factor in all these requirements, completing the project on time and under budget. The station was designed, built, and fully outfitted in less than a year at a cost of $71,500, about the same as a well-equipped 25-foot cabin cruiser. To begin its operational phase, the Carpenter Station was transported by truck from the Kennedy Space Center to the Florida Keys. It was launched in Key Largo and towed to the Marine Resources Development Foundation's Undersea Training Center, where it was submerged and secured on the sea floor. A tour of the station demonstrates the basic requirements for supporting life on the surface of an alien world.
Just wanted to welcome you to the Carpenter Station and give you kind of a tour of the station and what we have in here. This is a very small compartment, as you can tell, but it is designed so that 3 aquanauts can live and work in here all the time. It's more comfortable with 2, as you can tell, but 3 aquanauts typically are living and working here. But let's start over here on this panel right here. What you see here, first of all, is an oxygen meter. It tells us our oxygen levels. This tells us our power levels that come into the station. This is our temperature monitoring for our air conditioning system and for the cabin air temperature. Most of our systems are designed to be 12-volt DC systems. That's the same as a car battery. And as you see, we can operate all of our control systems off of this one switch panel, which is easily accessible from either one of the seats. Now here's our AC controller. Now this is the same kind of power that you have coming into your home. Your home is powered by 110-volt AC power. And we have an air conditioner, which is 110-volt power, refrigerator, a microwave oven, and our outlets. These are all controlled from this panel right here. And these are just our panel light controllers that you see here. If we work on around the panel here, you can see 3 large dials. When we go out on the reef into the ocean itself, we can power between our battery pods, which are operated from these 2 switches, or we can operate from both of our battery pods at the same time. If we have a power outage, we can turn this dial and have emergency power to the station anytime we want it. This is a very interesting panel here. It converts 12 volts DC into 110 volts AC so that we can use battery power to power our air conditioner, refrigerator, and microwave oven. This is another interesting device here. This converts 110 volts into 12 volts, so we can go either way on our power distribution system. This is where the cool air comes from the air conditioner, this little vent right here. And as we move on around, this is our microwave oven where we prepare our meals. And this is a television and VCR. We can watch training and educational films on this particular machine right here. This is our light controllers. We control all the lights inside the station with this panel, and this is our weather station. This shows us the weather conditions on the surface at any time. You move around the cockpit here, we have a clock that just tells us the regular time on the surface. Now, we do have a connection with the surface in the form of a surface buoy. I think you can see that right there in that image. And our surface buoy has what we call strobe lights. There are 2 lights on the buoy. One is an orange flashing light, which makes sure that boats do not come near us, and it flashes about once a second. And right below that is an emergency strobe light. It is a white strobe light that indicates to the people on the surface that we're having an emergency. Now, when we're close to shore, sometimes we can get air shipped down to us in very large quantities. What that air does is it bubbles out all of the carbon dioxide so it doesn't build up inside. And what you're looking at now is the airstream as it comes out of the station, and that is all of the extra air that we don't need, and that's carrying away all of the carbon dioxide away from the station. What you're looking through is a bubble. It's a glass bubble at the top of the station. And I think you have seen some outside views of this bubble from in the water. But it allows us to look in a 360-degree arc all around the station so that we can see all around us at any time. One of the neat things about the station is that we have windows all around us. And from any window you can see either the surface or you can look down and see the bottom. So it's a very useful feature of this station, being able to see all around you all the time.
During its first undersea mission, the station operated continuously for 31 days and hosted dozens of visitors, including aquanauts, scientists, teachers, and even an astronaut. Station crews conducted a total of 21 classroom telephone links with Mars schools in Florida, Michigan, and Oklahoma, answering questions about space life sciences and space analogs, while increasing student interest in sciences and the space program. An example of a typical exchange occurred when students at Homestead High School in South Florida asked Dennis about conditions on board the station.
Hello, my name is Osman Ruz and I'm from Homestead Senior High School, and I want to know if the CO2 scrubber is turned on or not.
The question is the CO2 scrubber working or do we have it turned off? We have it turned off right now because we're receiving enough fresh air.
While underwater, the station also connected with NASA's Ames Research Center in California, and with a NASA crew participating in a prolonged space life support systems test at the Johnson Space Center in Houston, and with a school north of the Arctic Circle on Canada's Baffin Island. The station's final 11-day mission ran concurrently with one performed by the Space Shuttle Atlantis, mission STS-86. Atlantis carried 3.5 million tomato seeds that were exposed to the vacuum of space in a gas or getaway special payload canister. The Carpenter Station carried an identical cargo at its seafloor location 27 feet under the sea at a pressure of 1.7 atmospheres. The seeds had been carefully prepared, packaged, and stowed on board the shuttle and inside the Carpenter Station, exposing them to the harsh conditions of space and ocean environments. The effects of that exposure on the seeds would be determined later as students across the country would perform experiments into the effects of extreme environments on plant growth. After the Carpenter Station completed its first underwater mission, its primary function shifted to become an educational ambassador for NASA, visiting schools and other learning centers to share with students hands-on encounters with a working space station analog. At the station's official commissioning ceremony, held at the Kennedy Space Center's visitor complex last November, Congressman Dave Weldon shared with assembled students the station's #1 goal.
This station is a uniquely well-designed and technological tool, a tool that will operate in one of the most difficult areas known to man. In fact, the environment that this tool will operate in is largely unexplored and remains unknown in large degree. In fact, it is thought by many to be impossible to predict, but important to control. I am not talking about outer space. I am not talking about even the underwater environment where this space analog station will operate. I am talking about the uncharted area between the ears of our nation's youth, especially those K through 12, where knowledge cannot be well stored or easily accessed without the ingredients of inspiration and purpose. That's what the Scott Carpenter Space Analog Station is designed for. And believe me, if we are to continue to succeed as a spacefaring nation, we will need the youth in the K through 12 classrooms of today to serve in the capsules of tomorrow's Mars missions, moon outposts, and interplanetary explorations. I am proud of the part that Florida has and will play in our nation's space program, and I am convinced that the Scott Carpenter Space Analog Station will play a large and important role in that mission for years to come.
Weldon was joined by former Space Shuttle pilot and current Kennedy Space Center Director Roy Bridges, who added his thoughts about the station.
As Congressman Weldon said, the Carpenter Station is intended to inspire many to be explorers. And of course, the critical thing is to spark the imagination so that we will have new scientists, engineers, astronauts, aquanauts, and others who will continue to push back the boundaries of human knowledge and experience. We're a lot smarter today than when Scott Carpenter flew in space, a lot smarter than when I flew in space. But I think what we have really revealed is just how much more we have to learn, how many more places there are to go, how many more discoveries there are to be made. Perhaps the Scott Carpenter Station will be the spark that ignites the fire in the bellies of someone in the audience today to continue to open that frontier of knowledge for the benefit of all of us on Earth.
Finally, Scott Carpenter shared his views about the importance of the station bearing his name.
It represents the growing awareness of the potential for technology transfer between the ocean and space. We have both gleaned a lot of information that is transferred between the two, and that information teaches all us older folks more about where we are, who we are, and where we're going. It's an expression of curiosity, which is our finest gift. Once we satisfy that curiosity, we have new knowledge. And the most important thing we can do with that new knowledge is to pass it on to you younger folks. You're going to be taking over for us soon, and the best thing we can do with our knowledge is give it to you.
Almost 40 years have passed since Scott was selected to become one of the original Mercury 7 astronauts. During that time, NASA's mandate has remained to lead the nation's exploration initiatives on the high frontier. Today, thanks to the vision of NASA's Dr. Joan Vernikos, the director of NASA Space Life Sciences, initiatives like the Scott Carpenter Space Analog Station are bringing the excitement of the space program directly to students so they can touch, feel, and connect with the concepts of space life sciences, and perhaps become inspired to follow careers into space. Exploring space is not merely an exercise in flexing scientific muscle. And while it is complicated, it's not just rocket science. It's about adapting to new environments through the study of space life sciences, finding ways to improve our quality of life, and bringing those benefits down to Earth for as many as possible. In the process, we learn more about who we are as a people and who we want to become. Throughout the history of our civilization, human development has followed the path of explorers and pioneers, from Mediterranean adventurers and ocean-going sea merchants to the first men that walked on the moon and the astronauts that are shuttling us into a new millennium. We have always grown as our horizons were expanded before us. Those horizons are expanding at an ever greater rate today, and our world is about to become a much bigger place as America leads the way to new frontiers in space, and NASA sets the course for that adventure. The first steps are already being taken with the assembly of the International Space Station, new missions to the Moon, Mars, other planets in our solar system, and beyond. To prepare for our future, we'll need bright young minds with a passion for learning and discovery, fueled by the excitement of exploration and supported by the work of previous generations. These new pioneers will take us places we only dreamed of going. We stand on the edge of a promising tomorrow where the sky is no longer a limit, but a threshold for adventure. The journey begins today. in classrooms across America.